Hello there, YouTube and makers. Thank you so much for joining me here today. And thank you very much for sharing your time with me, especially now on the latest installment of making axles for the tender of the Kozo Hiraoka Pennsylvania A-3 switcher steam locomotive engine in 3/4 inch scale to run on a 3.5 inch gauge track and is in a 040 layout. I'll be demonstrating how I machine the axle end for the tender. Here, it's going to be kind of important because we run into our first set of tolerances and some of the very few tolerances that are listed in the book. And these axle ends are going to be made up to the tender wheels as well as be the surface that interacts with the bearings, which will be riding inside of the journal boxes for the tender's trucks. These tolerances for the bearings leave us less than a thousandth of an inch of a range. And on the mating surface, which between the axles and the tender wheels is even less generous, only providing for a mere 5/10,000ths of an inch range. So that is half of a thousandth of an inch. Absolutely tiny and small. The thickness of a piece of paper generally, the thickness of a generic piece of paper is 0.0044. So 4,000ths and 4/10,000ths, or 44/10,000ths. So then, if you can imagine something being about a ninth of the thickness of a piece of paper. That ninth is all the room for error and range available in order to make that shoulder, or rather that area that shoulders or butts to and interacts with the tender wheels. Good machining here has long-term consequences for my overall make. Poor machining on the axle tips means that there will be a bad interaction between the axle and the bearings, which could lead to squeaky operating and poor performance, and maybe a little bit of friction and a bit sluggish and uneven friction sluggish if one end is smoother than the other. Likewise, not properly controlling the overall length of the axle means that the gauge that's going to be 3.5 inches, so the gauge between the two tender wheels is going to be off. And having bad gauging here means that the tender, as well as any trucks or wagons or rolling stock that I've derived from these axles and these extra tender wheels that I'm also making concurrently, will be at risk for being poor operating, possibly rough riding, and even worse, prone to derailment. And derailment means that there will be track damage, equipment damage, the tender and locomotive can be damaged, and anyone operating on the locomotive or riding in any of the rolling stock or around it may be placed in peril by those derailments. I want to make sure that I am very careful here, because I won't necessarily know that there's an issue unless it's all put together and I have some way of gauging these axles and tender wheels on a truck. Or even worse yet, I may not really understand that there's an issue until I go to operate the completed locomotive way down the line and find that it doesn't operate well because of, and I don't want that cause to be because of poorly machined and poorly controlled gauging on my tender or any kind of rolling stock. To help me control and to machine the gauging of these axles really comes into play today's journeyman trick of the day. So that you never miss a journeyman trick of the day, be sure to hit that subscribe button as well as a bell notification so you never miss an installment of one of my videos nor any of my journeyman tips and tricks of the day. And in this trick, I'm going to be covering something called touching off. I'd used it before in videos, but didn't really understand it. I kind of knew what the concept is from the name, and I heard it thrown about. But I took the time to really sit down with the journey machinist and understand what touching off is and how to do it. And so I've got 3 really good techniques that I'll be demonstrating on how to touch off. Not only touching off, but I will actually use them on an axle. And then after machining both ends of the axle and machining it to length, we'll find out if that touching off means that that axle is going to be within spec of 4.750 inches, and the proper gauging has been set. A micrometer is going to be absolutely invaluable here. So I'm going to try to take a moment, and hopefully I'll remember to post the search that I use to find my micrometer or a good vintage micrometer. So be sure to check out the description below for that. Now, join me over here at the bench and let's make some chips.
As always, I'm going to begin by using my dial indicator and kind of getting the piece in there to run as true as possible. Starting off with good ground material, I was able to get it within a couple thousandths right off the bat. I want to begin by facing. Now, I believe the cut length of these pieces are 0.485 and 0.49 overall. We send and drill it as called for by Kozo Hiraoka. If you'll remember, this is a tip from a previous installment in which the fluid is up. And I put the oil in there, cutting fluid in there, so that it kind of pools. It seems to work, and it seems as it cuts to wick it away and bring it into the face of the part being cut. Now I'm going to measure out by using the dials the distance and double check that with my calipers for the surface to be machined for the axles per Kozo Hiraoka. And in my instance, it took about 26 turns and about like 34 thousandths, I believe. And then of course I'm going to zero it once I kind of got the diameter. See, it took a little off. I didn't like the mark that left, so I went back and plunged it in there a little bit deeper, so I had a strong visual. But I'm going to take my first 10 thousandths off. As you can see with the combination of my cutting fluid, the angle of the titanium carbide cutter, it makes a really nice finish with this metal. I wish I could tell you exactly what it was, but it was a cold rolled ground that I got at my local steel supplier. Just for fun, let's call him an iron monger. So another 10 thousandths off. I'm trying not to do any back cuts, but I inadvertently do now and then. Oh, I was a little short there, so go back. I'm not having too much good luck with the back cuts with these cutters and this material. I keep playing with it, but as you can see, by not doing the back cuts, I get a near mirror finish. So I already wiped it off. I'm going to take a little measurement to see where I'm at. And I'm looking at 338, 0.338. So fortunately it's a little blurry here, but you can see it's at the 3 and the 25 thousandths mark, plus an additional 13 thou. Unfortunately, because it was blurry, I couldn't tell you what the 10,000 position is. So I'll take off about another 10 thousandths. And then did another back cut. You see, just did not like that finish. I don't know why I keep trying to make it work. But I know some people do it, some people don't. But it's just not been working well for me. So another dab of cutting fluid each and every time. And I'm basically going to take a pressure cut. And keep my same previous settings. I'm blowing a little bit too long there, it's a bit dangerous. And because I didn't take anything off, I just ran it back to see what would happen. Again, see, not much of anything came off, if any. So another little wipey wipe. And get all the chips off so I don't get any kind of false readings. Let's see where we are at here. Yeah, not a super big fan of that back cut finish. Nice and tight. Oh, gotta double check to see if it's warm or not. And we are now down to 0.3241. See, nice and clear this time. I have no idea what it did. But you can see the 1 line and the 3 line up the most, indicating the 10,000 position of 1. Remember from the roughing out portion, I roughly left myself about 12 thousandths off the diameter. So I really only need to remove 6,000 off the radius. But I'm not going to do that in one go. You just saw here that I took off about 4 thousandths. And then I'm going to take a pressure cut here and measure where I'm at. See where I'm going, because it is kind of a balance between removing the correct amount of material in one go versus continuously taking these light cuts and risking work hardening the surface. Here I'm at, let's see, 0.3143, so a couple thousandths off the diameter, which means just a thou off the radius out. This is about a thousandths cut. And then I'm going to plunge in real quick and square off that shoulder. And measure and see where I'm at. Because I only took off a thou, I don't really feel the need to go in deep. So 0.31, let's see, the 3 lines up. So 0.3133. And I'm basically taking these pressure cuts, and it's a risk. I remove the least amount of material, but then in the process, by not adequately getting through that surface, I am work hardening it. So let's see where we're at. And see there, I'm at 0.3129. The book calls for between 0.3125 0.3120. So I'm 4 10,000ths over the max recommended by Kozo. And I'm, see the 24 lines of line right there. And I'm gonna try dry fitting some of these wheels to see where that, because Kozo calls for using Loctite or some other sealant material on there to basically glue the wheels to the axle. So I'm not averse to having an oversized wheel, since it's going to be basically stuck together. But let's see what that fit is like. So I'm not going to test one, I'm going to test several. And in the process of testing several, I also saw that my work doing the reaming was very good, and that they were all very consistent in the tightness and fit on this end of the axle of the several samples I tried. So it is nice. See, I am struggling to get it on and off. Let's double check to make sure I got enough of the end removed on the axle, and it ends up lining up very nicely with the calipers. So I do have the right amount removed. So I've reset my calipers to measure out the 0.2656 N of the axle, which will be seated inside of a bearing inside of the journal box for the tender wheel bogies. So I've already measured that out with my cross slide and plunged in and mark it off to the correct depth I need. So that's the nice thing about zeroing everything. Take a little plunge cut, square up that shoulder, and continue to move. On this end, because it is a bearing surface, I'm really not going to do much more than 10,000 at a crack, I think. Took another back cut, but you know I can get away with it because I know I've got another 10,000 or so to go, so it won't be an issue. Get that chip out of the way, and let's find out where we're at. Came back to it a little bit later because it felt warm enough. So let's see where we're at. Well, we're going to be at 0.2558. Just making sure that bird is not going to affect my measurement. Or rather, there is no bird to affect my measurement. At 58 10,000ths, or 0.0058, I have just under 6 thousandths left to remove from the diameter. And what that equates to in terms of radius is half that, so that's less than 3 thousandths of material left to remove. To get to that 0.249 to 0.248 range is called out for in Kozo's book. So it's going to be this very delicate dance of removing just enough material. So here I've gone in probably about 2 thousandths. And took that darn back cut again, but now I'm going to take a pressure cut. And let's see where we are at. So looks like at 0.251. So less than 2 thousandths. So a thousandths off the cut. So I'm trying to do a pressure cut, and as you can see, it's just not taking off any material. And it's just basically moving, a few little chips coming off, but it's just basically scraping off cutting fluid. So I'm gonna just have to go for it, go in a thou, and take it off. And of course, squaring off the shoulder and taking my obligatory pressure cut, finish cut. And let's see where we're done. Do I have some left to go? I did take too much. Well, I am right where I want to be. Right in the mid-range of 0.249 and 0.248. So I'm at 2.485. So 5 10,000ths right in between the two. And that's exactly where I want to be.
Now that my axle end has been machined, I need to bring the overall length in to 4.750 inches. And this is particularly important because with the overall length is how I'm going to set the portion that will interact with the bearing, as well as the portion or shoulder that's going to interact with the tender wheel. What I gathered from the book is that to finish off the overall axle length, I'll be taking a facing cut and then memorizing the position of the dials, removing it from the chalk, remeasuring the overall length, repositioning it, and memorizing the length and removing some amount, and then removing it again and checking the overall length and making corrections from there. That's a little bit difficult and a bit tedious. There's kind of got to be a way to just kind of accurately measure length over and over again. Both of the journeyman machinist and the journeyman tool and die maker, told me that I want to remove the piece I'm working on as little as possible. I want a good few setups as possible, because despite indicating in and dialing everything in, removing a piece and putting it in and out constantly is a constant source of inaccuracies and variation. And to reduce those inaccuracies and variation, I want as few movements and operation of my piece or axle as possible. What Kozo, I think, alludes to is a term that I had used but didn't really understand myself, as I mentioned earlier in the beginning of the video, called touching off. And I got a little bit of a crash course from the journeyman machinist on how to touch off. And that brings us to our journeyman tip of the day. So that you never miss an installment of any of my videos or a journeyman tip or trick of the day, be sure to hit that subscribe button as well as the bell notification. And if you end up enjoying the video and found the journeyman tips or tricks of the day useful, also hit that like button. It really helps me out and I appreciate it. Also, if you have any advice or tip or trick for machining that you think might be useful, please comment below. I'd really like to hear from you, and I'd really like the opportunity to maybe feature it on a future installment as a journeyman tip or trick of the day. Let's check out 3 ways of touching off. So come on over here and join me at the bench, and let's make some chips.
I want to make sure that I'm cutting against a dead flat surface. I don't want some wonky weird end like what's pictured at the left, where I could be touching off and measuring from here, or maybe here, or over here. It's not consistent and it's not good practice. I want my face, the workpiece I'm machining, to be absolutely dead flat, perfect and perpendicular to center line, where the axle is rotating around. And this is absolutely important when getting an overall length and establishing how much material I need to remove. Otherwise, I get stuck in this vicious cycle of chucking it and unchucking it and remeasuring it, cutting off a few couple thousandths here and there, going back and forth, and not making a good, consistent clean practice. This first method of touching off is kind of what Kozo Hiraoka alluded to in the book, in which we're going to gently bring the cutter into the face of the piece that we're machining and just barely touch it or touch up. Touching off, depending on, now you can hear it when it touches it, and I first purposely turn up the volume. You can see it leaves a little bit of line, but touching off will engrave into the face of the workpiece by 1/1000 to 3/1000, depending on how much slop and how heavy-handed the operator is using. And you can see I'm pointing out where it just touched off and marked the face of it. And I can set my 0 to that and know that the next cut will be, based on experience, about 1/1000 to 3/1000 off, depending on the machine, how heavy-handed. This next method the journeyman recommended is called the paper method, because I'm calling it that because it uses a piece of paper. Paper can be surprisingly consistent in thickness, and as a matter of fact, the journeyman tool and die maker has a preferred piece of paper, well, rather a notebook, and brand that is used for years and years and years, because from lot to lot, batch to batch, this manufacturer and this paper pad is very consistent and exactly the same thickness. So the paper thickness is 44/10,000ths. So I know when it touches 44/10,000ths. So I'm going to turn my machine on, and I'm going to bring my cutter and kind of keep the paper moving and floating into just until I feel the paper catch. And when the paper catches, then I know I have approximately 2.5–3 thousandths away from the face of my workpiece. And of course, it depends on how sloppy the machine is. But because this machine is very consistent, has very little backlash, and is very repeatable, I know that when using the paper method, it's going to be about 3 thousandths every time. In this one, I'm going to use blue dicam. And if you don't know how to apply blue dicam, check out my last journeyman trick in which I talk about applying blue dicam, because it's very important that it's properly applied. Because depending on how many coats and how thick it is, blue dicam can be anywhere from 15 10,000ths to 35 10,000ths thickness. And in this method, I'm going to just touch off by rubbing off the blue dicam. And if it's not properly applied, dried, and a consistent thickness, it'll be difficult to know. So as you can see, I'm rubbing off the blue dicam and it just appears. It might have been a little bit heavy-handed, but it looks like really I've only got just a tiny bit of chips on there from a pressure cut, and mostly blue dicam on the end of that cutter. So there, because, and this is where kind of the art of it comes in, from experience and doing it over and over again, I'll know how much from the application of blue dicam is, how much thickness is removed. And in this case, it does indeed translate out to be very accurately 15 10,000ths. And now I can begin bringing my axle length into the overall length. What's nice, because I know exactly where I'm at and I've already zeroed my hand wheel, I can just take these nice 15 20 thousandths cut and really feel like what the machine wants to do and let the machine cut the way it wants to cut. So instead of taking these really tiny little piddly couple thousandths here and measuring, a couple thousand there and measuring, I could take the cuts that this cutter and this machine wants to make. And that works out very well. And we won't see how well this method works out until the very end, when I give you a real, unabridged view to see where I'm at. Now, I do have to say, I am going to bring it to probably not the 76 thou left. I'm probably going to bring it more closely, I think, probably to 70 thou. Then give it a moment to cool off, and then, because feeling it here, it is quite warm. So I'm going to give it a little break, and then I'm going to take my last 5 thousandths off, so roughly 75 thousandths off instead of 76 thousandths. Again, compensating for expansion due to heat. And then I'm going to go ahead, when that's all done, I'm going to probably do all the rest of my machine. Oh, but first a pressure cut here. Make it nice and clean and true. But I'm going to put that shoulder on, and then I'm going to put that bearing surface in that goes into the bearing. And then we'll see where we're at the end.
That is the journeyman trick of the day. We'll see here in a moment whether or not it works. But first, I'm going to machine this other end of the axle, and I'm not going to change. I'm going to do it exactly the way I just did it because it works. So, after investing all this time and energy to machine both ends and to machine it down to length, I have no idea whether or not it's going to be the right overall length. So you'll see here in real time, as I did, whether or not this works out. Did I scrap the part by making it too short? Did I make it too long? Which too long might not be as bad, because I can always trim off or nip off a little bit off the end. So we'll see. Let's take a look.
Actually, I'm pretty nervous at this point because I didn't know what it was going to end up being. And for some reason, I just could not handle and pick up this axle. I kept dropping it. I've dropped it like 3 times. And I had the most difficult time getting it set up. My calipers, but a little bit of fiddling and adjusting. It locked in there. Look at that. Only 5 10,000ths over, so whew, that's a relief. Just a word on these calipers is that these digital calipers, as I understand it, that's not actually 5 10,000ths, but represents kind of a range from 5/10,000ths and 9/10,000ths before it moves into the next upper interval of a thousandths. So it is a little bit of a range. So it could be the 5/10,000ths or the 9/10,000ths, but I think that's acceptable. Or at least I hope it is. So, but here I'm going to be doing the last step for these axles, and that is chamfering the ends that will made up to the bearings in the axle boxes. So I didn't have the specific tool illustrated by Kozo Hiraoka. I'm just kind of adapting with what I have. I found in my C package is this what I think is a high-speed steel boring bar. So I'm just going to kind of use it and just kind of chamfer the end and touch it off real lightly and easy. Not the exact tool as shown in the book, and probably not the best tool for the job, but what I am doing is just living with and adapting to what I have and making the best, so that I think it'll be alright and do the same job. I'm just kind of orientated to the way it shows the correct tool in the book. And I'm just going to put a very diminutive and light chamfer on here to get things going and get this piece finished. So it doesn't take much. And it seemed alright. Well, again, very light. Not much going on there.
After considerable thought and consternation, I decided to go back and machine that solder or section which interacts with the tender wheel. I applied today's journeyman trick of the day, which I brought the cutter in just enough to touch and barely make a perceptible mark, and with that took a light pressure cut. And I'm happy to report I did get that solder down to 0.3125. So at the upper range of the dimensions specified by Kozo, but in range. And it's still a very snug and very nice fit with the tender wheels. Now that that axle is completed, I can begin to join parts. I can take 3 parts and join them with 2 tender wheels and make 1 assembly. All I have to do now is make another 3 axles, and I've got all of my tender wheel and axle combinations for the tender. What is really cool and really energizing about getting to this point in the book and this point in my make is that I'm no longer making individual pieces. I am making pieces that assemble into other pieces and making larger, more complicated assemblies. So that's a really great, really energizing, and makes me really enthusiastic for this make. Now, whether or not I was wrong or right to leave that little extra 5/10,000ths at the end of the axle remains to be seen. But it is a very small amount to remove, so we shall see in the immediate future. But I did come across a set of guidelines or specifications for operating on a club track. And once I kind of get tease those out and understand what's going on, I'm going to basically assemble a few sets of tender wheels and axles and gauge them against the specifications of this club track and determine whether or not these tender wheels can operate as on a track as specified by the rules and guidelines of this organization. In future installments, I'm going to be taking this brass bar, which is 5/8, and turning it into journal boxes, as well as a couple of these phosphor bronze bars and turning them into bearings. And those bearings are what will interact with the ends of the axles, with which I just machined, as well as the journal boxes for the trucks on the tender of the Kozo Hiraoka Pennsylvania A-3 switcher steam locomotive engine in 3/4 inch scale to run on a 3.5 inch gauge track in a 040 layout. So that you never miss any of those installments or a new Tool Friday unboxing and any of my journeyman tips or tricks of the day, be sure to hit that subscribe button and a bell notification so that you're alerted when those videos post. Also, if you enjoyed today's video or found today's journeyman's tip or trick of the day useful, be sure to hit that like button. As well as feel free to share my videos and comment below. I always enjoy the opportunity to engage with you guys and gals and to see what's going on and to hear your feedback. Thank you so much for spending your time with me and sharing it with me. And I hope you enjoyed that. Till next time, stay safe, have fun, and keep making chips.